Good afternoon, everybody. My name is Mitch Robertson, and I'm coming back to you with a whole nother video series, um, kind of related to today's things that are going on. As everybody currently knows, with this COVID-19 thing, everybody or a lot of companies have sent people home to work from home, and it's creating some interesting challenges. I mean, if that's the norm for the company, it's not such a big deal. But believe it or not, there are a lot of users out there that have never ever worked from home. And so they don't understand all the challenges that are happening. And the problem is a lot of these a lot of people complain and they call the help desk, and the help desk really, because they haven't done this before, hasn't really learned how to chase these type of problems. So I'm going to kind of walk through some things and try to do some live demonstrations. I haven't done this before. Most of my videos have been PowerPoint backed, and so when I did the PowerPoint, did the recording and uploaded it, all was good. So this time we're going to try to do some live stuff on the with me actually doing some demonstrations of some testing and some things we can check and validate and just see what's going on within a person's network. So we're going to start by kind of discussing the what are some of the potential issues that people complain about on VPN. And it's interesting to me because most of the time the end users, it'd be great if they call in and say, hey, I've got poor bandwidth, or I've got a latency problem, or hey, I've got a packet loss problem. Um, since it's only about 10% of the population that actually works in IT, and this is going to be an uncommon complaint. Most people, they just turn on their computer and it just works, or it doesn't work, or it doesn't work the way they expect it to. And with today's networks, being working at home or working at the office all the time, most people are used to things working pretty smoothly. So now they move to working from home, and you'll start to get these um, complaints of things like freezing applications. I'm working in Excel, it's doing great, and all of a sudden it hangs up. And so when that happens, they call the support desk or they complain to their management that this just doesn't work for me, and they're frustrated. And with everything going on with COVID-19, people are frustrated, people are challenged. And so it's causing some extra calls to support desks and to people, and their management wants to help them have a better experience. So oftentimes these things even get escalated to tier 3. And so like on the freezing applications, something to think about is like Excel. Excel is a common one that has this problem. People don't realize that in Excel there's a auto save function that happens every 10 minutes. That auto save function, if it happens across a high latency network, which I'll explain here in a little bit, could create some challenges for you and could cause it to freeze. In some cases, it kicks them completely off their VPN session, just drops them completely out. If those kind of things happen, that's really bad, because then they have to reconnect, or they see the VPN client come up and say, hey, reconnecting. And those things are scary, and they worry about what it's causing to their efficiency. And in today's current environment, with 30% of the workforce being laid off, people are worried about their jobs. So they're trying very hard to be sure that they're providing value to the company. And if they're always getting kicked off, or they're always having freezing applications, they're getting frustrated and pretty upset with it. Applications that are slow to respond, things like having to click on it multiple times. So when it all starts up and I click on Outlook and I clicked on it and it didn't immediately pop up, or I click on Excel and it didn't immediately pop up. Those kind of things do happen depending on how your applications are deployed, right? Poor voice quality, poor video. So all of these type of complaints are the things that you're going to get at the help desk, and sometimes raised up to tier 1, tier 2, tier 3 support. Interesting thing is a lot of the causes are either bandwidth related. The person doesn't have enough bandwidth available, and I'll show you some of that happening, or try to at least. Latency. If you have high latency on the network, it causes everything, and generally anything over about 300 milliseconds is going to be pretty impactful to the end users. In some cases, 100 to 150 milliseconds can be impacting to the end user, and they can notice it pretty cleanly, or pretty clearly. Packet loss is huge. Well, how do I troubleshoot this stuff? High CPU on the client. If you're using VDI, maybe it's high CPU on the VDI. Maybe it's high CPU on the client itself. So with those things going on, you kind of have to know how to troubleshoot those issues. And the best thing is if you can get some type of remote connectivity to their machine, you can start to get a better idea of the problems that are happening before you or in front of you. If you have tools that already capture packets and grab metrics on your network, then you should be able to see what's going on if it's inside your network and be able to tell fairly quickly. So take advantage of all the tools, spend some time, learn how to troubleshoot these issues, and I'm going to walk through some of them and try to give you some examples of some of them as we go through. So in order for you to troubleshoot all this, it's really important for you to know what IP the user is coming from. In years past, it was easy. We just went in and we spent a little bit of time with them and talked to them on the browser and said, hey, on your browser, type in whatismyip.com, right? And when they did that, you would get an IP address that's usually another IPv6 address, and everything was great and fine and dandy. But today we're seeing these cases where IPv6 addresses are coming up in these test tools, and it doesn't give you any sort of IPv4 translation or anything that you can find out what the IPv4 address is. And problem of it is a lot of medium-sized businesses are still running IPv4 on their internet-facing side, and all they ever see is IPv4 addresses coming to them because the IPv6 doesn't route to them. So I'm going to explain some of that and how that works and tell you how to get some of this information or some ways you might be able to get some of this information if it absolutely became necessary. It does create some challenges. So here's my user, and this is a little bit incorrect because normally even on an IPv6 network like Cox Internet, the end user inside of their network is going to have like a 192.168.1.5 or something like that. They might also have an IPv6. Matter of fact, many computers have IPv6. Most corporations haven't turned it off. It's on. So oftentimes you're going to see both sets of addresses. And so that's okay. What we're really concerned about is this address that's on the front of their firewall, right? So their provider has given them an IPv6 address. And what is seen when they go to the what is my IP, love my writing doing this, they go to what is my IP, and they generally see this address right here. So that throws everybody off. You can do things like go to some speed test networks, try for some speed test networks that are on different vendors, because there's quite a few speed tests. Google has one, Microsoft has one. Oftentimes those often have content delivery networks where they're on distributed networks that are distributed to each one of the vendors. So Cox has one, AT&T has one, those kind of things. So you really generally get what IP Cox has assigned you or AT&T has assigned you. But if you move around a little bit, you might be able to find several different sites that might give you the IPv4 address as it comes through the translation gateway. And what I'm talking about there is when your packet comes out and is going to my VPN concentrator or my website, what it does is it hits what's called an IPv6 to IPv4 bridge. Some people call it a bridge. Some people will call it V4 to V6 to V4 tunnel. There's some device on their network that is taking all of that traffic and acting as a gateway and converting it to an IPv4 network. And so a lot of times this acts like a NAT router because this IP address down here, if you have two users on the same network, you might end up having both of them coming out this IP that you now would see .x.5. So both users might come out the same IP. It's possible, and I have not spent a ton of time to research how all of these are set up yet, but it appears to me to be that this is the case, and I'm still doing some testing to validate this. However, it still is helpful knowing this address, because that's what's going to actually come in and hit your gateway. So your VPN logs, if you're tapped on the outside, this is the IP address that you're going to see. If you look at your server that this is hitting in the IIS logs or the packets that are coming through, the origin IP or the exported for IP is going to be this IP that you're going to see. And so that data is what you're looking for to try to do more troubleshooting. Challenge with this is you're only going to be able to get so much information looking on your network side of things. So if you start looking at your side of things, you're only going to kind of be able to see from this perspective, right? If you spend a little bit of time and get tools like ping plotter, traceroute, some of those things, you might find that those tools give you more information about next hop. And so it would show you on a trace route, it would show from here to here, here to here, here to here, and here to here, and then going to here, and it depends on if these are actually participating in ICMP or not. So traceroute oftentimes can help you, and so let me give you a kind of a scenario of how some things that you can do to help figure this out. In the situations that I've never been able to find what this IPv4 or IPv6 to IPv4 gateway IP is, I've done things like just simply started a continuous ping, and as I see they go through, then I watch my outside interface right here and look for ICMP packets, right? And as I see those ICMP packets and a large volume of them, a decent volume of them, and I can adjust the MTU size on it, I might be able to tell that that's coming from that device, and then I can kind of denote that IP if I don't have a lot of people doing ICMP. And so that's one of the ways that I've been able to get the IP on cases that I needed to really spend some time troubleshooting. So that's a good thing. But I want to talk about this a little bit more. By understanding this and understanding what's happening from network to network, you can really start to troubleshoot things. So for me, the other day, my network started to have problems. And so on Monday, I was on several conference calls and I was doing a lot of work. And I noticed around 11 o'clock in the morning, I started having some performance issues. And so I started doing pings to our outside of our VPN gateway, and I started doing some pings into our network, and I was seeing 1,000 milliseconds of latency, right? That's not good. I could tell that was a big problem. So as I'm pinging this, I'm trying to figure out what's going on. And this began to bother me a lot more. And so I'm going to demonstrate this or show this to you in Revealx and let you see how it actually worked. But one of the things I ended up doing is I did a tracert. And I don't have a screenshot of it. I wish I did. Wasn't thinking about showing this. But what happened is my first hop between here and I've got a router that sits out here that's my provider's router somewhere. It's not at my house. Between here and here, it was 745 milliseconds. So I already knew that my latency was being injected right here. So that became a concern. These hops going out here, not near as bad, right? So I started to focus on this right here, and I'm going to get back to that here in just a few minutes. But having this kind of information and knowing how to troubleshoot that, and I'm going to do some of these tests and show you some of these tests and show you some differences between them here in just a minute, that becomes important for me to troubleshoot and for me to help tell my end users, especially if I can get on their machine, I can tell them, here's where some of your problems are, right? This is happening before it ever even gets to this system over here, which is where the corporate side is. So want to test this, want to validate it, want to be sure what's actually going on. It's really kind of important to understand it. But before I even get to that, I want to show you another example of where having taps and the right information in your environment can help you be successful at troubleshooting things. So in this case, I had an end user that was getting kicked off of our network or kicked off of my network. They were VPNing into me. And this was traffic was taken on the outside interface of my VPN, and I can see right away that this was inbound traffic, not outbound. So inbound traffic was dropped almost immediately, right? And so I can see these 2 times it dropped completely. Now I didn't get to spend a ton of time researching this because after we heard about the problem, it started to stabilize. So from about this time on, it pretty much stabilized and we didn't have a problem again. But we could definitely see that they were completely being dropped out. No packets were being sent between us or them. And so we were wanting to spend some time and dig into this. And so having this kind of data gives you information pretty quick. And if you have the inside information, so I'm going to draw this out. So let's say you have your firewall on the inside. And this trace was taken from the tap that sits right here, right? This is on the outside. And you have your user that is as their firewall, right? And this is the user. So right now, I know that packets stopped right here, either direction. If I have taps on the inside of this interface, so I actually have a tap that sits right here. Now I should be able to see what it was that sent the buy or closed the traffic. If, depending on the type of firewall you have or type of VPN solution, so like let's say this is Citrix, right? This is Citrix NetScaler. It terminates and reconnects the session back here. So if I've got a Citrix VDI instance and this is staying connected, but traffic drops out here, all the way out here, but this stays connected, then odds are it's on this side, right? So that helps me kind of dig into, is this a problem on our side or is this a problem between here and here, right? Or actually I would go all the way back to here because this is a problem here all the way back to here. So having the information and knowing what dropped it is kind of valuable. So having the ability to look at your wired data on the inside of your network and on the outside of your network does pay off. And this is one of the things that, and one of the reasons I like wired data is I can find these things and oftentimes I can find them pretty quick. So something to think about as we kind of move through this, but I'm going to go back to teaching or showing you some of the steps I used and some of the tools I used and some of the ways I was troubleshooting some things. And we're going to start off with my Monday's incident. So I'm going to bounce around a little bit and I apologize for that, but that's the way I like to work. On Monday, I started noticing that I had some latency issues, but if you look at this PC that I'm on, my Surface, you can see that it really wasn't doing a whole lot. I had a little bit of outbound traffic, not a lot of inbound traffic. It wasn't doing a whole lot, but I was having problems, and so I'm not using a lot of bandwidth. So I'm like, what's going on here? What really concerns me? So I started looking at this network a little bit further, and look at that. I started having some latency right in here. That became an issue and became somewhat of a concern, right? And so I can see I'm having up to 1,000 milliseconds of latency. That's just not good. And so now I want to start digging into what's going on. And as I showed you earlier, that in this, I was noticing that it was right in this area that the problem was. I wanted to dig more into that because I felt like it was coming from my network. And I got to looking at this a little bit more and got to thinking about it. And so immediately, first thing I do in Revealx is I kind of focus in on the time frame. So I'm going to take a look at that high latency time period and go to right here to see what is actually going on. And we can see that latency pretty blatantly there, right? You can see the 5th percentile is up in the 500 milliseconds, and I have times that I get up in the 1,000 milliseconds or greater, right? And my averages start looking pretty bad. So my average is 944, or my 95th percentile is 944 milliseconds. The median is 109 milliseconds, but I've got some periods where it's pretty good, which helps draw this down. got to think about averages when you're dealing with this kind of thing. So pretty cool. So I'm going to take this and I'm going to go look at my wife's machine because she was busy doing some things. And whoa, look at that. And one of the things that jumped out at me immediately that I didn't notice at first was this detection. So I have a data exfil. She's moving a lot of data, and you can see this is a large amount of data that's being moved out of the environment, right? And so it's during that time frame that I have things going on, and so I'm kind of concerned about that. What's actually happening there? I wonder whether these data exfils, when data is moving out, is that during my high latency, and is she experiencing the same problem? Whoa, let's take a look at that. So now we've got this data out, and look at that. My data starts going out at 1:25 p.m. and right here, about 1:25, right? It starts to drop out at about 2:30, starts to drop out around 2:30, 2:45, right? Same thing, it starts back up again around 3:10, starts back up around 3:05, 3:10, my data starts going up. And what I found is she was copying videos up to the cloud for something she was doing. And she had accidentally made 4 copies of the same video and pulled it in a folder that's supposed to be replicated up. So all 4 videos, even though they're the same video, were replicating up. Now, needless to say, this is a big problem because not only this is affecting my work, it is also affecting some other things that are going on in the network. My kids are upset because the Xbox isn't working anymore. My daughters can't do their schoolwork for college anymore. So everybody's getting pretty riled up. And interesting thing, my family has a bunch of Zoom meetings that kick off between 6:15 and 6:30. So I've got to get this fixed pretty fast. So I got started looking at it and I found where I could turn down and throttle the bandwidth that was being used by this application. So I'm going to extend this time out a little bit more. And we're going to take it to 2200, just so you get an idea of what actually happened. And you can see during the time period, so I throttled the connection outbound, and it really moved just a small amount of data, just trucking along. You can see my Zoom stuff or her Zoom stuff on that same PC kicked off, started working. So this is bits doing its thing, and you can see it's capped. I mean, it's not going any higher than this, so you can tell that's a cap. It's one of the coolest things about Revealx is you can start to see where things are capped at because you see these very flat lines, which is not normal for data in most cases unless it's capped somewhere. So now I've got this cap going on, and I see the Zoom meetings start to happen. Everybody gets through. They get done. My wife brings me her computer and says, hey, we need to get this finished up. And I knocked out the 3 that weren't supposed to be there. And I turned it back up to full throttle and let it go. And boom, it dumps the rest of the data up to finish the download of the file. And look at that. My latency was nice and fine during me throttling all that data. So latency becomes a really big key. And believe it or not, during that latency problem, which was caused by a bandwidth problem at my own house, right? If this bandwidth problem was happening out on the internet somewhere and it was affecting a router or something at your ISP, you wouldn't see this. What you would see is this high latency going on. So yes, I caused this. My wife and I caused this problem. Okay, not a big deal. Pretty cool that we could find it and I could see it pretty quick. One other thing that I kind of want to show you is during that time, I was doing pings out to a couple of things to see what was going on. Let's see, ICMP2, I had 2 destination unreachable, right? So I'm not going to dig into those because there's other things to that, but let's go look at my machine. That was my wife's machine. Sorry, that wasn't mine. This was mine. And we will notice on mine the pings that I was pinging to kind of test all this. You could tell that I had 915 pings went out. I had 907 return. So I had some packet loss. Not a large amount, but I definitely had some packet loss. Now, looking at that, I would really need to spend some time and look at the time frame that I did those 915 packets, and did all that packet loss happen at once in a 30-second period or something like that, or was it distributed over a 30-minute period? those are things that I don't have the statistics on. I could get them real easy by digging into this, but I don't want to dig into this just yet. So pretty cool when you can see this kind of thing. And if you take a look at, what was it? Tuesday, you can see I was doing pings as well. And in this case, I could see that I was doing pings and do the IP, and I could see that I was doing pings to Google, right? So from my environment to Google, I was seeing what the latency looked at like. So I want to take a few minutes and just kind of show you how that works. So we're going to pull up a command prompt, and I'm going to do some pings and some different ways of pinging. So everybody knows the standard ping, www.google.com. So right there, I've already tested. I know that I got name resolution. I now know the IP of Google. I know that my latency, the first packet was 122 milliseconds. Everything else kind of settled down to 72 to 83 milliseconds. But that was with 32 bytes of data. So now what if I want to take that same thing and do a -L, which is adding length or adding packets, and we're going to bump this up to 1480. Okay, cool. So now I've fully loaded that packet, and I get a response back. My latency is a little bit higher. So notice the difference. Now that I'm putting a load on it, I actually have higher latency. And so I tend to like to do these kind of things by doing a -T to keep it going for a longer period of time. But one of the things that I've had quite a bit of experience in and found quite a few problems with is I oftentimes like to do what's called the -F. And so we're going to do that, and look at that. We get this thing called packet needs to be fragmented at 1480. What's the maximum MTU size of a packet on most networks? It's 1500. So right now I got 20 bytes that is being chopped off, or it tells me I need to be fragmented. And believe it or not, every single browser out there, so when you browse data, it automatically adds the -F bit. And so do some other things. So when you have applications that aren't performing correctly or having problems, it's always a good idea to check the MTU size that's actually being passed through. Now there's normally overhead added by VPNs and other things like that. So 1470, I still need to be, and I don't have any VPN going. I don't have any overhead that's going in my environment. So in my environment, let's just find out. Wow, that's interesting. 60, 1450, good grief. Didn't see this before, but that's cool. Okay, at 1440, I can get packets through. Nope, can't, sorry, thought I could. So let's take it even down further, 1430. Now I start to get packets. So I've got 70 bytes of overhead somewhere that's being added to my network for one reason or another, right? And you can see with a fully loaded packet, 1430, look at that. Look at some of the latency that I had versus do the same thing without the -F and without the -L. Or for that matter, I can just set the -F. It'll go through because it's only 32 bytes, right? Look at the difference in the latency. I don't have very many places that I hit 100 milliseconds. So this is one of the things that I like to test in environments. I might keep pinging the VPN gateway. I might ping the other end gateway. But as I'm doing that, I also may want to hit, do a trace route, right? So and this may take a second to do. You can see my gateway is what most people's home gateways are. But then the next hop is this 74.221, and it's a 41 millisecond latency, right? So that's okay. I don't have anything injected. So my bigger hop is this Denver level 3, and I'm going to Dallas level 3. So now I've gone to Denver and then out to Dallas. So I've gone from where I live in Kansas out to Denver and then to Dallas. And then I can follow this all the way through and see where it ends up, right? So that ends up at Google somewhere. I know at least made it to Dallas, right? But I can see if I had high latency right here at my first hop, that would be my bigger concern, right? Path Ping plotter. Ping plotter is a tool that I like to use, and it does the same thing in. Oh, it'll close here. Give me a minute. I'm on a trial license. So it does the same kind of thing as a trace route, but it does it all the time, right? So if I'm going to do www.google.com, we do that, and we see the latency that's injected at different, man, we've got packet loss at this Bear Washington level 3, right? So that becomes a bigger problem that we have to pay attention to. However, packet loss at a router, probably not a big deal because a lot of them will drop ICMP because it's a lower level. It's not, it's queued differently. So maybe not a problem because we're getting fairly return times. So something to think about as a part of this process. But this is a way of testing out some of the environments, right? And just seeing the same thing. It's the exact same thing that you see in the tracert, right? Except for it's constant. So it's constant, basically doing a continuous tracert. Cool tool, nice to have, but can I get the same information for point in time information off of a tracert? Absolutely, I can. So these are some tests that you want to do. So I highly recommend that you look up things like the -F. Why is that? Maybe something you might be interested in, right? The ping, ping-f, ping-l, ping-l 1430, -t. If you don't know these and you've never used them and you've been in IT a while, you might want to spend some time digging into it. Coolest thing ever is the ability to use that within the Revealx and seeing what's actually happening with those packets, right? ICMP data is extremely important to chasing down problems and can help you in a lot of issues that are happening. So pay attention to your bandwidth and your latency. You already saw some of the issues that I had. You can see some of the latency that's happening in my environment. Let's look at how it's going today. Let's look at the last 6 hours. I don't think the surface was doing much of anything today. So it was on, had some stuff going on, but packet rate's not much. Packet type, my latency round trips time was 200 milliseconds, and I live in the country, and so I'm not really getting excited about that. And that's maximums, that's 95th percentile. The majority of my time I'm in the 220. You know, my average is 63.5 milliseconds is my average, so that's pretty good. So anyway, this is something that I'm going to start doing more. I hope this was of value to you. I hope you get something out of it. And I'm going to start doing more of these demonstrations of Revealx. If you haven't seen it, I recommend that you go spend some time at their website. They've got a great demonstration that you can go to. If you go to extrahop.com, you can get out here and you can actually start their demo, and it's a free floating demo, so you can actually get in and change things and look at things and play with things a little bit more. But this is a pretty powerful tool, has a lot of cool features with security detections, and tells me a lot about my devices that I have on my network and the type of devices and all of those type of things, and my gateways and my web servers. All of that sort of stuff I can see just based off of wired data. This is purely passive. It's purely getting information and making determination about the information off of wired data. And I'm going to continue to do videos to kind of show you how important wired data is. So hope this was valuable. Take some time, subscribe, click the like button. I really appreciate it, and have a great evening.